whatever you have learned here about tiles. So tiles are made, and when tiles are made, then there is a rejection also. And in India, whatever you make nowadays, waste generation, overall waste generation of municipality, and industrial waste, that your IT, this software companies, hardware, software waste. So you can imagine almost 1,000 tons of means computer, all that software waste. In Bangalore it is 1,000 tons per month. 1,000 tons. How to dispose is also a. So now, but you know that software, all that is production is not as, that is low density product, and tiles are high density product. So this waste is Morbi is the biggest up throughout world. Okay. So how much waste they generate? So when they generate, suppose you take example 1,000 tons waste generation. So 1,000 tons waste generation, 12% they 10 to 12% they utilize in that new composition, whatever tiles manufacturing. So 12% of that. So almost 120 tons they will utilize. Rest 880 tons is lying here and there only. Correct, no? So this now, this whatever we are working on this at present, this is geopolymer part. Okay. Now in ceramics, geopolymer means, somebody will think polymer means chemistry. Geo means whatever that raw materials, natural raw materials, and raw materials which have taken means like rock shape. So tiles becomes like rock. Okay. So those raw materials will be used here, and when they are added with some chemicals, they behave like polymers. So they have given them geopolymer. But now this geopolymer part which we are talking, that is, it was existing earlier, but nobody knew. So now this I will show you. So many, maybe 300 years back, people have used this, but they did not know that this is something. So this means terminology came up in the 1980s. Ukraine scientists have this. Dendovit or that fellow has discovered this. Okay, so I will go more technical with this key. Then it is very interesting. We have utilized granite waste from Kerala. So one gun did that project. Then we have utilized, then we have done another project, Khurja pottery waste utilization, that we have done. And we have taken whole Khurja pottery waste and we made sculpture, you know. Sculpture students will need that all, that hammer and chisel, all that, and make the shape, visual art shape, all that, statues, all that. So we have made almost 200 kg blocks in Khurja, and those blocks we sent to this Delhi, that Muslim university, Jamia Millia Fine Arts Faculty. We gave those blocks, and they have made some statues, you can say visual art kind of statues, and then they made and gave back to us. वो हॉल में रखा हुआ है, and then whatever what they were doing earlier, they will take the stone, big stones, and then they will do all that carving, breaking, all that sizzling, all that they will do, and then make the statue. So now by waste we can make it. Okay. So this is next. So objective of this technology is waste utilization, and use the waste, make value added products, and it is like circular economy. This is so waste to wealth, and this is, as I said, this is green technology. Okay, and the products whatever we make, it will be environment friendly. Yes. Now what the geopolymers? Okay, so silica means SiO, Si, all this plays major bonding role. Okay, then we put alumina. So aluminosilicate is part of our life, like for metallurgy, na? So for ceramist, alumina silica phase diagram is important. For metallurgist, iron carbon phase diagram is important. Okay, they talk ours also. We mix different raw materials, and you say in their terminology, you can say that we are getting a lot. Okay, so this is raw materials, all we will take, because silica is important. The silicon based raw materials will be there, and all these raw materials coming from rock. So rock forming, and rock is related to geology. So geology, then its name came Geopolymer. Okay, and as I said, Davidovich in 1978, I told 83, 78 he gave this name, Ukraine scientist. So inorganic geopolymer and organic geopolymer, but we will be talking about inorganic geopolymer. Next. Even this palace, whole earthquake came. Earthquake was there, and Modi ji came last time. He inaugurated that earthquake memorial in this Bhuj palace. Nothing happened. So this also, and they have done all spectroscopy, all those things, and analyzed and found that it may not be exactly the calculations correct, but geopolymeric reaction has been found in this. Next. Geopolymer based in USA, whole building is made with this. In India also this kind of buildings are made. It is there. Next. When 200 years back, this governor of Utah state in USA, the building is 200 years old. This was building and this thing, and I have gone there and seen this, and American scientists, some people, they took me there. They said this is geopolymer based building. This building, that's why this place I have gone to Salt Lake City, US. Railway, the track is being made by this. In this and Moscow, they have made the track. Next, it is future, technology of the future, and for all, and importantly, it is waste utilization. So now this, suppose US means India and is not manufacturer, US Portland Cement Association, they have told 4,700 mg per ton of that Portland cement manufacturing energy is required. For this it is like 150 to 200. So this is about that comparison about cement both and civil engineering. Lot of work is being done for civil engineering part. If I have all the details, is being done at our CSIR lab in IIT Roorkee. The person here, he has done work not only fly ash based, and they have made almost 1.5 kilometer road by fly ash utilization in NTPC plant, that is Ghaziabad, and that road is do you know that 10 ton track or something, and from the edge they have tested, edge means 0.5% of the edge also is not damaged. By 10 ton track just gone on the edge. So this energy need, if you see, geopolymer cement. So in that, slag also is big problem for steel plants. So slag can be used. You go to the iron ore mines, ore will come out and side all that waste. Iron ore mine, that also can be used. The iron ore mines waste will give you better strength. So this 59% is the energy saving there. Portland cement, suppose calcination, this, okay. So Portland cement is this much, GP cement 59%, and suppose you use slag in that, so 43% energy will be less. All that cement, slag, when you make slag also byproduct, 80% energy saving is there. All that different composition, different slags, they have used and shown that it is this much energy saving. CO2 emissions also during manufacturing is highly comparable and very low in this case. Next. This is my presentation. Very short.